Hi everyone. We're going to graph h of x as a piecewise defined function in two pieces. Alright, and we're going to test for continuity at x equals -2 because this is where all the action's happening around this. It's changing. These are both linear functions, but they change at x equals -2. And then we're going to evaluate the function at these four x values. So the first thing we're going to do is I should have wrote this down. We have h of x equals 1/2 x minus 4 at x is less than or equal to -2, and 3 minus 2x if x is bigger than -2. Alright, so we want to test for continuity. And for the continuity, for this function to be continuous, it has to meet all three conditions in this order. So it wants to see what's going on if it's continuous at where it's changing here. The functions are changing. So at x equals -2, that's our c. Our c is -2. So let's plug that in. H of -2, we can plug it into this upper portion because that's where it equals it. So if I plug that in, I get 1/2 times -2 minus 4. So the 2's cancel, so you get -1 minus 4, that equals -5. So we do have a f of c. It happens to be -5. Alright, now we have to see if the left and right hand side limits match. So we're going to check the limit as x approaches -2 from the left. That means all numbers smaller than -2. That means -3, -4, things like that. That limit has to match all the numbers bigger than -2. That means -1, 0, and so forth. So the limit as x approaches -2 from the right. And so all you do is you plug in these two values into your function. So if you plug in -2 to the upper portion, we already did that, and that equals -5. And so this has to match this side. So if I plug in from the right, all the numbers right of 2 is what that means. You plug in, you write 3 minus 2 times -2. So that's going to be 3, 2 negatives make a positive. So that's going to be plus 4. And that equals 7. Well, it looks like these two do not equal each other, so the limit does not exist here. That means this function is not going to be continuous. It means there's going to be some kind of discontinuity involved. So let's graph and see really what's going on. Again, I should have wrote these out. So we have h of x, let me do it very quickly, equals 1/2 x minus 4. That's when x is less than or equal to -2, and 3 minus 2x if x is greater than -2. So all the actions occurring around this -2 mark on the x. So let's see what's happening at -2. When I plugged in -2, we already did that. We got -5. So let's go 1, 2, 3, 4, 5. And it can equal it. Alright, now the slope is 1/2. So if you want, just go down 1 over 2, so you don't really have to plug in anything more. So at -4, that would be -2 minus 4 is -6. This is -5, -6. So you can either just plug in points or just kind of graph it on the left side of -2. So these are all the numbers left of 2 here, like that. Alright, now what's going on the right-hand side of -2? Well, that's all numbers bigger than -2. So again, if I plug in -2 here, that's going to equal 7. So 3 plus 4 is 7. And I didn't save room for that. So I'm going to have to move this over a little bit. So I'm just going to move that a little bit. So at -2, we're going up to 7, which is about here. All right, this was x is less than -2. So, but it can't equal it. So I'm going to draw an open interval here. It's open. We're going to call this -7. All right, then let's see what's going on at 0. If I plug in 0 for x, I'm at 3. So that's your y-intercept. So this graph is going like this. And this is why condition 2 failed, because the limit, as you're getting closer and closer to -2 from the left, equals -5, but the limit as you approach -2 on the x from the right was -7. So this is called a jump discontinuity. And that's why condition 2 failed. All right. And then we have to do our evaluating. So we're trying to evaluate h of -4. I really apologize for not writing this down earlier. I usually do. And h of 6. Again, our function was 1/2 x minus 4. X is less than or equal to -2. And 3 minus 2x. X is greater than -2. So all you're doing is plugging into the appropriate piece. So -4 there. That goes into the first portion. So when you plug in -4, you're going to get 1/2 -4 minus 4. So this is going to go in -2. That's going to be -2 minus 4 is -6. So this equals -6. All right, if I plug in -2, we already did that one. That's going to equal -5. If I plug in -1, let's try that one. -1. So it's, -1 has to go into this one because -1 is bigger than -2. So we're going to go 3 minus 2 times -1. This is going to be 3 plus 3, which equals 6. So this is 6. And if you plug in 6, this is still going to go into the, I keep messing up on this one, plug into the second one. So you plug in 6 here. And that's going to give you 3 minus 12, which equals -9. So that's just evaluating here. So this equals. Okay, that's it. Thank you. Have a nice day. Bye-bye.